Let's suppose we have just 3 switches. The switches are A, B, and C here. And we have a certain number of lamps. And we want to control these lamps using just 3 switches. And the question is, how many different lamps we can control using just 3 switches? By control, I mean that I can switch on or off each or the lamps, each one, but in any moment just one lamp or no one is on. So for example, I can switch on this one and the other all off, or I can switch on light on this one and the other are all off, or I can switch off all the lamps, but I cannot have 2 lamps or 3 or 4 together switched on. So just one at any time or none at all. So how many lamps? We can study this problem using Logisim, and I can represent our 3 switches using just 3 input pins. I call them A, B, and C. And I can represent, of course, the lamp using some LED diodes, some LED. So we have 3 input pins. How many lamps, how many LED can I switch on and off? The first answer may be you could think 3 LED, one for the first switch, another for the second one, and a third for the third switch. But this is not true, because in this case I can of course switch on off any lamp, any LED, but I can also switch on 2 LED at the same time, and this is not required by our assumption. I told that just one lamp at any time can be switched on. So this solution is too rich. It allows to light up 3 LEDs together, and this is not required. So if we don't want to light up 2 or more LED at the same time, the answer is that we can control a total of 7 different LED. And now I'm going to explain you how does it work. These are 7 LEDs. So when I have 0, 0, 0, let us suppose that all our LED are off, as in this case. When I write here the code 001, for example, this is the number 1 in binary code, if you read it in this order, 001. So putting here the code 1, I can light up, switch on the first lamp. And in the same way, with number 2, I can switch on the second lamp with number 3, the third lamp with number 4, the fourth lamp, and so on till number 7, which is the maximum number I can write in binary using just 3 bits. So with number 7, I can control the lamp number 7. And of course, there are 7 lamps because 2 raised to the power of 3, because we have 3 bits, makes 8, and we have 8 configuration here, and the configuration 0 is used to switch off all the lamps, and any other configuration is used to control 1 or of the 7 lamps. So here I need a circuit called a decoder. A decoder is in general a circuit that receives in input a code, a binary number, and in output it produces some output depending on the code which I give in input. I show an example now. I'm going to add a new circuit and I call it End Decoder. So inside this circuit I put 3 input pins, A, B, and C, and I put also 7 output pin, which represent our lamps, and the 7 output pin should be L1 for the first lamp, L2 for the second one, and so on. So now I go to analyze circuit, and this is the truth table of our circuit. Let's say that when we have 0, 0, 0, I want to have all the lamps switched off, so 0, 0, 0 in all the columns in this table, and with the code 001, I want to switch on the first lamp and the other remains at 0, and with the code 2, I want to light up the second lamp, and so on. So you see, this is our truth table, and it's a truth table with a particular shape because in each row there is just one bit at value 1, and all the other bits in any row are 0 because just one lamp is on and the other are off. So let's build the circuit, and now I'm using this circuit in our main circuit. I drag our decoder here and connect these 3 to A, B, and C, and then I connected the lamp, so this one is lamp 1, and this is 2, and so on. And now we can try our circuit, and with code 000 all the lamps are off. With 001 just this one is on and the other are off. With the code 010, which is number 2, just this second lamp is on. Number 3, number 4, number 5, number 6, and number 7. So you see this decoder takes a binary code, a binary number here, and transform this binary number is 1 in 7 different outputs.